Today we're continuing to talk about alkenes and alkynes, and we want to understand how we name them as well as how they affect the shapes of molecules. So naming alkenes and alkynes is still pretty straightforward, but they do change the rules a little bit. Because what happens with alkenes and alkynes is that the double bond and the triple bond are more important to the chemical's properties than any branches it has. So whereas with alkanes we prioritized having the lowest number on all of the branches, with alkenes and alkynes we are going to prioritize having the lowest number on the double bond or the triple bond. If both are present, then we will add up the numbers for all the double bonds and triple bonds and figure out whichever one is lowest. That's going to be the one that the numbering scheme we're going to use. If you have two possibilities where a double bond and a triple bond are both the lowest, then we're going to prioritize the double bond over the triple bond. You are never going to have to do that on the diploma though. So, first thing we're going to do is we're going to figure out what the longest chains of carbons that contain the multiple bonds are. And we're going to minimize the numbers associated with those double bonds and or triple bonds. Once we have our numbering scheme, we're going to identify the type and location of each branch, and then we're going to write it out in a similar format. The branches are going to go first, the parent name prefix is going to go next, and then we're going to indicate the number of the double and or triple bonds, followed by -ine or -ine as appropriate. These are more chemically relevant because they change the shape of the molecule more than the branches do. You'll often hear me say shape determines properties, both physical and chemical. In an alkane, we have a whole bunch of tetrahedral shapes. So we get this kind of zigzag pattern that can twist around really, really easily. But double bonds are going to force molecules into trigonal planar shapes. So they create these flat shapes in the molecules, and the important thing is that double bonds can't rotate. They're also slightly shorter than a single bond is, so it condenses the molecule a little bit. Triple bonds do a similar thing as well, but they of course will make a linear shape and they are even shorter still. So that changes the shape of the molecule. If you're dealing with a catalyst or an enzyme and you have some sort of lock and key structure, that shape is really, really important. As well, double bonds and triple bonds have specific reactivities, which we'll talk about later in this chapter, and that has a big influence on the chemical properties of whatever hydrocarbon they are a part of.